Hi guys, let me fix my Zoom here. Okay, so I didn't want to deal with this during lunch today, and then I had to grade unit circles during my Calc Honors class, so I'm going to attempt to redo this problem because I think I know what I did wrong, but I don't know. We'll see. So we want to find the arc length of this, right? So this is the one where I kind of got the answer right in class, but I screwed up in my arithmetic or something. So anyway, f prime of x. That's going to be, if I take the derivative of this, I bring the 3 down. 3 goes into 6 twice. I'm going to have x squared over 2 minus 1 over 2x squared. Right? And that's equal to 1/2. If I take that out, x squared minus 1 over x squared. So now if I square this derivative, I'm going to get 1/4, go square that, and now if I square this, I'm going to have x to the 4th minus 2 plus 1 over x to the 4th. And if I distribute that in, I'm going to have 1/4 x to the 4th minus 1/2 plus 1 over 4x to the 4th. So the arc length is equal to the integral from 1/2 to 2 of the square root of 1 plus this stuff. Right? This is my derivative squared. And now if I add the 1/2 to that, I'm going to have 1/2 to 2. So that's going to be 1/4 x to the 4th plus 1/2 plus 1 over 4x to the 4th. I think that's another thing I might have done too, is I might have thought this was downstairs or something at some point. Not sure. Okay, so now I'm going to factor out 1/4. If I factor out 1/4, that's going to leave me with x to the 4th. Now 1/2 divided by 1/4 is 2. And plus 1 over x to the 4th. And that's going to give me this thing here can be factored to x squared plus 1 over x squared squared, which will be nice. So I just want to do a quick check on the side because I already screwed it up, so I don't want to do it again. If I FOIL this, right, I'm going to get x to the 4th plus 1 plus 1 plus 1 over x to the 4th. So yeah, it works. This is equivalent to that. So now, this is really nice because, you know, rules of exponents. If I have a product inside of an exponent, I can put them in their own houses, so to speak. And this is going to come out as 1/2. And this, the stuff inside, is going to come out of that square. These are going to cancel. And I'm going to pull that 1/2 out front. And then I just have a simple integration here. So that's going to be, let's say, 1/2 of x cubed over 3. Now if I integrate this, this is x to the minus 2, so I'm going to add 1 and divide by the same exponent, so minus 1 over x from 1/2 to 2. And let's see. If I plug the 2 in, I'm going to have 8/3 minus 1/2 minus, now if I plug the 1/2 in, that's going to be 1/8 times 3, or 1/24. 1/8 times 3 is 1/24 minus 1/2. No, sorry, minus 2. minus 2, right? 1 divided by 1/2 is 2. So this is going to be 1/2 of, I'm just going to cross multiply these, so this is going to be 16 minus 3 is 13 over 6, minus 24 times negative 2 is negative 48, plus 1 is negative 47 over 24. This is 1/2 of 13/6 then, plus 47 over 24. And if I multiply this fraction here by 4 over 4 to get my denominators the same, I'm going to have 1/2. 13 times 4 is 52 over 24, plus 47 over 24. And that's going to give me 1/2. That's going to be 24. 52, 7 and 2 is 9, and 5 and 4 is 9. So there we go. And 3 goes into 99 33 times, and 3 goes into 24 8 times. So that gives us 33 over 16, and I believe, I don't have a copy of the book here, but I believe that was the answer. So if you want to check, you just have to look up arc length in the index to find the page number, and this is one of the examples that we did. This is one of the examples in the book, so it'll have the answer there for you to check, but I believe that's how it goes. I hope that helped. Sorry I screwed up the arithmetic or the integral or whatever it was I made the mistake on, and I'll see you on Wednesday.